All right, welcome to Math A, Graphing Inequalities. This is going to be day one. Some of you have done this already, so some people might just be watching this video for some extra help. So what is an inequality? So an inequality means that it approaches or gets really close to a value if we're using either the greater than or the less than sign. That means that all answers can be bigger or smaller than, but does not include that number. Oppositely, if we're using greater than or equal to or less than or equal to, our number that we get as our answer can be included on that. So say you have a budget, so you have your allowance and you end up going to the mall with some friends, and you don't want to spend no more than $60. Well, technically you can spend the $60 or anything lower than that. So in that case, you would use the less than or equal to sign. Say you're having a party and you can only have 10 people in there. Well, you can't have 10 extra people because you're there, so you can only have 9, right? So you want less than 10 people to show up. Okay, so when we start solving our actual inequalities, we're going to approach this like regular equations. The only difference is that when you multiply by a negative, you flip that inequality sign. So that means if it was this when you divide by the negative, if it was less than, when you divide it becomes greater than. If it was greater than or equal to, it becomes less than or equal to. We'll talk about these different types of shadings in a second once we solve our first equation, and then how to do our actual shading. So first steps first. I want to get x on one side by itself. Right now I have minus 2 plus x. If this was a regular equation of negative 11 is equal to negative 2 plus x, all I would simply do is add that 2 over. Well, same thing is true when I'm dealing with inequalities. So I'm going to add 2. Negative 11 plus 2 is negative 9. So I get negative 9 is greater than x. When I read inequalities, I want my x to be on the left side. So what I need to do here is rewrite this inequality. So I have x and I have my negative 9. In my green statement, my negative 9 is getting eaten by my inequality. So when I rewrite it, my negative 9 needs to still be eaten by my inequality. The reason I want to change that sign around to have x on the left side is that it will help me graph. When I look for values that are smaller than negative 9, because that's what less than means, I know it's less than because I see the smaller sign, the smaller side of my sign first. I want stuff smaller than negative 9. If I go back to my green equation, that's saying that negative 9 is bigger than all my x values. Okay, if negative 9 is going to be bigger than all my x, that means my answers are going to therefore be smaller. So when I do regular inequalities, I look for whatever my number is, and I'm going to write a circle above it, draw a circle above that number. In this case, it's 9. I am not including this negative 9 in my answer, because if I go back to the last slide for a second, you'll notice that I am dealing with greater than or less than. That means that my dot is going to be open because it's not actually part of the solution. It means I can get really, 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 really close to negative 9, but I can't actually let negative 9 be my answer. Next, I need to talk about how I'm going to shade my inequality. Now, when I deal with inequalities, it means that I don't just have one potential answer. I have hundreds upon the hundreds. Well, the reason I wanted to rewrite my inequality sign with the less than, with my x on the left, excuse me, is because I'm going to take that sign of less than, I'm going to turn it into an arrow. It's going to tell me which way I'm going to shade. I can only do this trick, however, if my x is already on the left side. So in this first example, I have x is less than -9, so I have an open circle at -9, and I'm shading to the left. Sorry about the little pause there, guys. I realized I should probably go start my laundry before I forget again. Okay, so back to math. So let's take a look at solving the second equation. We have x over 4 is less than or equal to -8. First steps first is I want to get x by itself. So x is being divided by 4. We should all know that to undo division, we're going to multiply. 4's cancel out. I have x is less than or equal to -32. Because -8 times 4 is -32. So let's check. Is my x on the left side of the expression? It is. Great. So I'm going to go ahead and put a circle above 32. If you notice, I have that little sign underneath my less than sign. That means it's equal to. That means I can have that answer of 32. That is included, so I'm going to fill in that circle as best as I can. And next, I'm going to go ahead and figure out which way I'm going to shade. If I have the less than sign, I turn it into an arrow. I shade to the left. All right, let's look at these next two problems. Number 3, I have x plus 2. I always start with undoing my addition or subtraction if I've got it. So I'm going to subtract 2 from both sides. 6 minus 2 is 4. All right, I've managed to get x by itself on one side. So I notice that x is on the left. I can go ahead and do my graphing. I'm going to have an open circle at 4 because I do not include 4. It's not equal to. Take my sign, turn it into an arrow. Shade to the left. All right, number 4. I notice I have 7 times x. So to undo that multiplication, I'm going to divide. So I have x is less than or equal to -3. I have my x already on the left, so I can go ahead and put my dot above -3, and it has that equal to, so I can go ahead and fill that all the way in. I have a less than, so it shows my arrow is going to the left. Everything is getting smaller. Number 5. I'm going to undo that addition with subtraction. I get x is less than 12. I'm going to put an open circle above 12 because it's not included. I see that I have my x already on the left-hand side, so turn my sign into an arrow. We go to the left. Number 6, I'm going to get rid of that division, that multiplication. 4 times 5 gives me -20. I have -20 is greater than x, so I notice I need to rewrite that expression because I don't know which way my arrow is going to go yet. So I have x, I have -20. I notice that my 20 is going to be larger than x. I know that because I have the greater than sign. My bigger part is facing the 20. So I need to keep that equal, so when I rewrite it, the bigger part needs to face my -20 again. So I have x is less than -20. So I'm going to put an open circle above -20 because it does not include it. Here's my sign. Let's turn it into an arrow. Shade to the left. All right, number 7. add 2. I get 20 is less than x. We notice that my x is on the right-hand side, so we're going to go ahead and rewrite that. So it's on the left. So I've got my x and my 20. If I take a look at my sign, I see 20 gets the smaller side. So I want to make sure 20 gets the smaller side again. So x is greater than 20. So I'm going to find 20. I'm going to put an open circle because it's not equal to. I'm going to take my sign and I'm going to turn it into an arrow. And in this example, we're going to shade to the right. Number 8. I see I have 8 times x, so I'm going to undo my multiplication with division. 24 divided by 8 gives me 3. I'm going to find my 3 and I'm going to put a closed circle above it because it is equal to. That line underneath means or equal to. It is included, so I need to include it. I'm going to take my greater than sign off to the side, turn it into an arrow, and I shade it to the right. All right, number 9. Now, I see 2 plus x. I still want to get x by itself. Ask yourself, is that 2 positive or negative? It's positive, right? So how do I undo positive 2? Yeah, you got to subtract. So what I do to one side, I do to the other. So 9 minus 2 is 7. 7 is less than x. Oh, hey, I got to switch that around. I want x and 7. 7, I notice, has the smaller side, so I need to give it the smaller side again. I have an open circle above 7 because it is not included. Should start catching on that when I see greater than, I'm going to shade to the right. If you need to pull your sign off to the side and make your arrow, you are still more than welcome to. All right, number 10, I'm going to undo that division with multiplication. 2 times 4 gives me 8. I have 8 is greater than x, so I notice that my x does not come first. We need to rewrite that bad boy. My 8 got the larger side, so I'm going to give it the larger side again. It's going to be a filled in circle at 8. We're going to shade to the left. All right, I know that's all there is on there for your notes, but I want to talk about something that I didn't have an example of, but was on the notes. Say I'm trying to find negative 8x is less than 24. All right, well, if I'm solving this like a normal one, I would divide by negative 8. So I get x by itself on one side. 24 divided by negative 8 gives me negative 3. But I want to draw our attention back to something in the very first slide. So bear with me for a second. We go all the way back. If you multiply or divide by a negative number, you're going to flip the inequality sign. So when I do that division, because I divided by negative 8, my sign will no longer be given the x the bigger side. It's going to flip to the smaller side. Now, I'm going to show you why. Pretend you left it the same as x was greater than negative 3. Let's pick a value that is bigger than negative 3 and try plugging in to my original equation. Would you agree with me that 0 is larger than negative 3? Okay. If I plugged in 0 for x, I would have negative 8 times 0 is greater than 24. Well, what's negative 8 times 0? 0. So then you get the expression 0 is greater than 24. Hey guys, is $0 bigger than $24? No, it's not a true statement. When you end up multiplying or dividing by a negative sign, you switch the location you want your answer to be in now. So if we take a look at the actual answer when we flipped it correctly, let's find a value that is smaller than negative 3. Let's try negative 10. So if I took negative 8 times negative 10, will that value be greater than 24? Negative 8 times negative 10 gives me a positive 80. Is 80 greater than 24? It is. When you deal with that negative signs, you have to account for having your negative times negative. Well, that negative times negative ends up making it turn positive in the end. And that's why you have to change your sign. So yes, I know, kind of a lot of crazy things in this example. But my answer is going to be x is less than negative 3. Here's my number line. 0 is over here. Negative 3 is over here. I have open circle going to the left. All right, thanks for watching.